Okay, please write down the heading, search in algorithm. So this is basically focusing on, right, how to search an element. Now we know how to sort a list, sort a set of elements. So we have to focus on search, finding an element, how to find an element in a list or tuple. So the easiest and the simplest way is called sequential search. Sequential search, that is easiest way and that is the simplest way of doing this, right? Please write the heading, sequential search. Right, in sequential search, how searching happens in sequential search? Basically in sequential search, so you search elements one by one, you search for an element and you check whether that element is matching with the search element. So that is the simplest way and that is called sequential search. So let me show this first. Let's say you have IDLE, and in this IDLE, so let me create a new file and create a list. File, new file. And I'm going to create a list here. My list, and in my list, I'm going to include elements. Let's include some elements. Okay, now you can see some elements are there in the list. And I want to search for a specific element. Let's say my search element, I'm going to take the search element from input. Let's say search element SC input, and I'm going to take integer input, integer enter and element, enter element for searching. I'm going to get that from the user, enter element for searching. And once they enter the element, I'm searching for element in my list. For element in my list, I can compare whether this element, if element is equal to the search element, so then you can say, let's say print search element. You can say string str search element with that space found, search element found. And if not, you can say search element not. Okay, first of all, let's write this. So that is why I said this is the simplest way. You have to just go through the list and search element by element. If element is matching the search element, you have to print that search element found. That's all. Right, let's run this now. Let's run this now. Let's save this as hello dot or searching dot py. Save it. And let me run the file. Then when we run this, it will ask enter the search element. Okay, I want to search whether tree is there, nothing come. So because tree is not there, let's search again and search element. Let's say 34 and it says 34 found. 34 found 2 times. So it says 34 here, 34 here. Actually, it found 2 times. Okay, let's assign this to a function. Then I can search again and again. Let's assign this to a function. Def search. In this function, I'm searching for this search element. Actually, search function, I'm searching for search element. Then I can rerun the function. I can run this again and again. Okay, so then nothing comes. I can search It's asking enter element to search. 45, not found. Enter element to search. 56, okay, 56 found. You can see. Again searching. Enter element search. Let's say 90. 90 found. Yes. Search again. Enter element for search. 45, not found. Enter element for search. 76. Enter element for search. 76, not found. Likewise, again, continue searching this. And continue searching the element. Okay, let's write down the algorithm for searching in sequential search. So you search item by item, right? So visit each item and search whether and see whether that item is similar to the search element. That is the simplest way of doing that, and you can write the code after that. Just write the code to search. Okay, I have not added not found one, right? So that can also be added. I can make it a sign like found equal false. For element in my list, I'm searching, and if found, I can make found equal true because I found that. And later, after traversing, I can say if not found, if not found, I can say print str search element not found. If not found, I can say str search element not found. And again, so I can reduce the number of times it tells, and else I can say print str search element found. I'm making this found only if I found this. If not found, I'm saying not found. If found, then I'm telling found. Let's run this again to see the difference. It's running now, and okay, I'm searching. I'm asking to search 34. Oh, what is that? Capital found. Sorry, it's my mistake. Should be simple found. Run it again. Search. Asking the element to search. 34 found. Now only one time. I'm telling 45 found. Okay, another one. 56 found. Oh, all elements are there. Let's say 23 not found. If it is not there, it will result not found. Right. You can copy the code, try this, and write down in your book. Please write down in your book after copying and trying the code. You can write down. I would like to ask small thing. Is there any possibility to shift the class to Sunday? Means Sunday same time. Do you have any classes on Sunday? Sunday 8 to 10. Is there any possibility?
I can't. I have a class.
You have a class, right? Okay. I just wanted to check, right? Okay. If not, it's okay. I just wanted to check. Okay. You can write down this. Okay. Before writing the second algorithm, I would like to write small thing. big O notation, big O notation or complexity for sequential search is ON. It's only ON, right? Because for other sorting algorithm, we learned that it is ON squared because number of comparisons, number of rounds repeat. It is n-1 into n-1. So ultimately it will give ON squared complexity. All sorting algorithms. But here in sequential search, it is only ON. And binary search is even faster than this. The second one is binary search. This is used when the list is sorted. This is used when list is sorted. It will start from the middle of the list, and the item and the search item is less than the middle item. Search item is less than the middle item. It will only search the left side. The left side. Continue to repeat until search item found or search list is over. It will continue to repeat until search item found or list is over. Okay, let me show this how this happening and all. So let's have a list. I'll keep the algorithm development part to you. You can do the algorithm development. So for the moment, I'll show how this is working. Okay, let's say this is the list. This should be sorted, right? List should be sorted. 12, 23, 34, 43, 45, 56, 68, 89, 92, say 100. Okay, so now you go to the, first of all, you have to find the number of items. Number of items 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's say search item. Search item is something like search item. Let's use an item which is not there in the list. 33 is the search item. Search item is 33. Number of items 10. Middle item can say 5. Middle item 5. You can either take 5 or you can just take 4 also, right? Because starting from 0, 1, 2, 3, 4 is also okay. 0, 1, 2, 3, 4 is also okay. Or you can take like 1, 2, 3, 4. So if you take 1, 2, 3, 4, 5, that is also okay. No big difference. So anyway, you have to start from middle. So let's say the middle item is 5. So first of all, you have to compare the item with 5. So the fifth item, 0th item, 1, 2, 3, 4, 5 is 56. Item is 56. So you have to compare. 33, is it less than 56? Yes. If it is yes, if yes, you have to forget about this part, because 33 less than 56 means you don't have 33 after this. You don't have 33 after this. 33 less than 56 means you don't have 33. Okay, then what you can do, so since you don't have 33, you have to come to the, it's not in the right part. Then item should be in left part. Item should be in the left part. Okay, then you have to take the middle of the left. Middle of the left means like 1, 2, 0, 1, 2, 3, 4. You have these items in the left side. Middle of the left is 34. That is item number 0, 1, 2. Middle of the left. I'll give you time to develop this, right? Middle of the left is item number 2. Because this is 5. It's not here. You have to search in this part. Middle of the list is 0, 1, 2. This is the middle, and that is item is now 34. And 33 less than 34. Yes. If yes, then item should be in the left part. Okay, you have again reduced this to half. Okay, let's say you are searching for 1 million item. You have 1 million item. First round it will become 500,000. Half of the item will be dropped. And the next round it will become 250,000. Half of the item dropped. Next round it will become 125,000. So likewise, half of the items dropped. Okay, let's say then left part. So what is the middle item? Middle item is 23. Middle item is 23. Then the middle is 1. Item is middle is 1. Item is 23. So 23, you take the 23. You have already dropped this one. May part drop kala thiyani. You take the 23. And the middle item is 23, it should be greater than, but you can't find the item greater than that, then stop searching. Okay, so now I explain the method. If you cannot understand, please ask. I'll explain again. So if you cannot understand the method, please ask, I'll explain again. I'm defining I'm defining another algorithm. So that is where, let's say binary search, B search. Def B search. And again, I can say, right, again, I can say the search, I have to view the search item similar to this. Search item, get using the input, it's not copied. Search item, I have to get using the input. After getting the search item, then I have to tell the law is, or the left or the low side is like the 0th element, and the high side or the end is, I can say start and end also. End is the length of the particular list. let's say length of my list. My list 2 my list 2. Length of my list 2. That is the sorted list. Okay, length of my list. And then okay, search element, low side, high side, mid. Actually, length of this -1 because you know length is not the list. You're starting from the 0. Length of the list is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But you know the high value is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 to 9. That's why length of list -1. And then the mid value can be taken by adding the low and high and dividing by 0, right? So you can take the mid value by adding the low and high and dividing by 0, but I'll keep that for the 0 because I have to recursively, repeatedly apply this. So now for the first time, if I'm going to find, it will find only one mid value. No? Therefore, I'm going to do this inside a loop while this low side is less than or equal to the high side. That means while it comes to the last one item, the one is equal to, that means low is equal to high means you have only one item, right? Let's say low is 0, high is also 0. That means you have only one item. While low is less than or equal to high, that means until it narrow down to one item, you have to recalculate the mid. That's why I'm not giving mid there. Then you can recalculate the mid by adding low to high and dividing it by 2. So I'm using floor division, right? Because I need integer value. That's why I'm using floor division. 2 division signs done. Floor division no normally. Okay. Then I'm checking if this mid value of the array or the list, my list 2, if this mid value is less than the search element, less than the search element. If so, you are going to search the left side. That means low side. Low side is equal to mid plus 1. I'm just editing the low side to mid plus 1. If this is less than, right? If this is less than, I have to check. And else I have to tell, okay, else if I have to check another else if, elif. Let me explain this one by one after writing. Elif, you can say my list 2, this mid item is greater than the search element. Right? If it is greater than the search element, then if it is greater than the search element, you have to actually change the other side. That means high side. High side is equal to, you can say mid minus 1. High side is equal to mid minus 1. High and low you change. And else, if nothing is there, so you have to just return the mid. If it is not less than, not greater than, which means it should be equal. If it is equal, then you are returning that. And let's say else, if nothing is there, so if it is not coming to this one or this one, so then finally you have to return -1. That means not found. Return. If it is not returning this one, not returning this one, finally return -1 means nothing is found. Okay. So then, okay, just run this now. Let's run this now and see. That is the second search function. B search. Okay, B search. I'm searching for 10. Oh, sorry. B search. It's asking the search item, searching for 10. Change -1 means not found, right? Yeah, 10 is not there. B search for 12. 0. It is the 0th index. Return the mid index. Actually, I have to return the item, right? I have to tell return my list to mid. 0 means the position. No? Okay, let's run this. B search, I'm searching for 34 and says 34. So I have to return a message like 34 found or not found likewise. So that can be done. So just returning, rather than just returning this, I can print str, this one, found. And here I have to print okay, print, simply I say not found. Search element, not found. SE, str, SE. Here also I can use str, right? str, not found. Okay, similar to the previous one. Let's run this again. And I'm searching, binary searching for element 56. Oh, it's not going to stop. I have to stop the algorithm, right? If it is found, it's found, it's always going. I have to increase while by 1, right? Always I have to while less, low, less, equal, high, right? That is correct. Okay, that is correct. Why is it recursively coming? Okay, so rather than just write in the print, I have to return this because I have to return from the, I have to exit from the function, right? If I print, it will print, but it will not exit. So after printing, let's see, can we return? Let's try to return, but it's not working. Basically, after finishing, after printing, let's try to return 1. Here, return 0. Normally after finishing, return won't work. Let's try this. Anyway, I'm searching, B search 56, 56. Yeah, now it's stopped, right? It's working. So no need to return, you can just say return. It's not return here also. No need to return number, just return. Then it won't be a problem. Okay, let's run this. Otherwise, it will not come out of the loop. It will keep rotating in the loop. B search, I'm searching for 45, found. Okay. B search, I'm searching for 55, not found. 55, it's not there. Okay, so you can write down this algorithm. And if anything unclear, I have implemented the same, right? If I have implemented the same, if it is less than this, I'm changing the low side, right? I'm changing the low side, I'm searching in the other part. If it is greater than if this mid item or if it is greater than, I'm checking it other way, right? If mid item is greater than the search element මම කලින් මේ පැත්තටනේ දැම්මේ. ඒකයි මේ විදිහට තියෙන්නේ. මේකේ search element එක මම අනෙක් පැත්තට දැම්මා. If search element is less than this, I'm changing the high side. කියන high එක මෙතනට දාගන්න. I'm searching this way. If search element is less than, I'm searching this side. So same algorithm. Okay, please add this algorithm to your search. Copy in and paste in here. You can write it. Let me know once you're done.